Hi, I'm going to show you how to do lesson 8.6, the Pythagorean theorem. The first warm-up says to find the area of this thing. So this thing right here appears to be some sort of square or something. So to find the area of a square or a rectangle, you do length times width. This length right here is A plus B. I need to multiply that by the width, which is also A plus B. Using the FOIL method, we're going to get A squared plus AB plus AB plus B squared. That comes out to A squared plus 2AB plus B squared. So that's the area. That's not the only way we could have done this. We also could have found the area of each individual triangle and then added on the area of the sideways square in the middle. The area of a triangle is 1/2 base times height. Okay, now the base of each triangle is A and the height is B. And there are 4 of the triangles. So this is the area of one triangle right here. If I multiply by 4, we will get the area of all 4 triangles. To find the area of the entire shape, we need to add in the area of the square in the middle, which the length and the width are both C of that middle square. So that makes an area of C squared. So this also must be the area of that thing right there. Well, if these both are the area, this and this, well, that must mean that those are actually equal. So that means A squared plus 2AB plus B squared must equal 4 times 1/2 AB plus C squared. Oops, I'm running out of room. There you go. All right. Oh, I'm in the middle of recording, Mr. Teaser. I'll be right over, though, for tea. 5 minutes. Okay, sounds good. All right, anyway, so if we do 4 times 1/2, that comes out to 2. Okay, so we end up with A squared plus 2AB plus B squared equals 2AB plus C squared. There's a 2AB on both sides, so those will cancel out, which leaves us with this equation, A squared plus B squared equals C squared. Thus concludes a simple proof of the Pythagorean theorem. That's assuming that these are right triangles, okay? We were operating under that assumption the entire time. But anyway, the rest of the lesson uses that Pythagorean equation. We're actually just going to skip this because the video is, I could show you the video. I'll attach the video. I won't bother doing the math problem, but I'll attach the video onto Teams. So, in any right triangle, this only works for right triangles, with leg lengths of A and B, that's what these sides in the triangle are called. These are legs. See, that's a leg. These are legs. And hypotenuse of length C, we have the equation A squared plus B squared equals C squared. This is always the longest side in the triangle. It's the hypotenuse, okay? So in this triangle right here, we'd notice that we don't know this side here. That is a leg. The hypotenuse is 50. It's the longest side. And we also know the other leg is 40. So if we use our Pythagorean equation, a squared plus b squared equals c squared, we have 40 squared plus b squared equals 50 squared. And we have to leave, we have to plug 50 in for c because it is the hypotenuse. 40 squared is 1600 plus b squared equals 2500. Subtract 1600 from both sides, you end up with b squared equals 900. Square root of both sides, we get b equals 30. Very good. Now, let's keep going. Find the length of the third side of each triangle if possible. Well, okay, let's do that. So this is a right triangle with legs of length 8 and 17. That is certainly possible. So we get 8 squared plus 17 squared equals c squared. Because the hypotenuse is the unknown, I have to leave c as c. I don't plug anything in for it. That gives us 64 plus 289 equals c squared. 64 plus 289 is 300 and I think it's 389 anyway, or 289, pretty sure. That comes out to 300 and, oh my gosh, 363. Is that right? I hope I'm doing this math right. I might want to check on a calculator. Hold on. Let's get the calculator. Let's just make sure I did 17 squared right. Yep, I did do that one right. And 64 plus, oh, you know what it is? Or wait, let me just make sure. 353, yes. So 353, oh, I put 363. 353, sorry. 353 equals c squared. Take the square root of both sides, you get c equals, uh-oh, I better get in the calculator for that too, huh? Let's see, calculator. What was it? 353, take the square root of that, please. 18 point, we'll say 8. 18.8. Okay. Luckily, I'm just going to skip to this third one. This one is not possible. And the reason is it's not a right triangle. So the equation does not work with right triangles. Okay? Not going to work. Let's try the middle one, though. So in the middle one, 41 is the hypotenuse. So we're going to have, I'm going to have to make room down here. Sorry. 40 squared plus b squared equals 41 squared. 40 squared is 1600 plus b squared equals, oh, 40 squared, what is that? Or 41 squared, I mean. 41 times 41 equals 1681. Okay, I should have known that. Subtract 1600 from both sides, and you're going to get b squared equals 81. Take the square root of both sides, we get b equals 9. Very good. Let's move on to example 5. Oops. Oh, goodness. What have I done? What have I done? Okay. Here we go. A steel rod is 14 feet long. Can it be laid down flat on a floor of a rectangular room that measures 9 feet by 12 feet? This rectangle is 9 by 12. So they're asking, could this rod fit? Could this rod fit right here? Basically asking, is that hypotenuse longer than 14 feet? That's really what they're asking. So we get 9 squared plus 12 squared equals c squared. That's 81 plus 144 equals c squared. 81 plus 144 is 225. Take the square root of both sides, and you get 15 equals c. So the answer is yes, because 15 is bigger than 14. So final answer is yes. Next one says, find the length of side TR using triangle TRL at right. So the hypotenuse is 29. So we get a squared plus 20 squared equals 29 squared. A squared plus 400 equals, let's see what 29 squared is. I feel like I should know this, but I don't. 841. Subtract 400. You're going to get a squared, equals 441. Take the square root of both sides. A equals, I need the calculator for that too. I put calendar. There we go. There's the calculator. 441, take the square root, 21 is your final answer. Should have known that one too. Sorry, I don't know these off the top of my head. I'm wasting your time. That concludes the video. Enjoy. Oh,